Hello to everyone. I am Professor Raja, working as Assistant Professor ECE, SNS College of Technology and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss about 23 ECET 221 Microprocessors and Microcontroller subject under Unit 5 Microcontroller Applications and Advanced Processor for the topic Architecture of ARM Processor. Already these students are studied about what is meant by microprocessor and how this microprocessor is varied from microcontroller. All the applications of microprocessor and microcontrollers are discussed. Now I will going to discuss about how the ARM processor is look like. ARM processor is an advanced version of 8086 processor where the memory size, the data input and the data output and the capability of storage medium are very high compared to a normal 8086 microprocessor. Let us move on to the video. Introduction to ARM architecture. ARM architecture is one of the most widely used processor architecture in the world, especially in embedded systems and mobile devices. It is designed to deliver high performance while consuming very low power. Because of its energy efficiency and simple instruction structure, ARM processors dominate smartphones, tablets, IoT devices, and many modern electronic systems. So, as you are an electronic engineer or computer science engineer, you must especially know about how the ARM processor are used in a real-time day-to-day applications. What is ARM architecture? ARM stands for Advanced RISC Machines. RISC means Reduced Instruction Set Computer, and the opposite version of RISC is CISC, Complex Instruction Set Computer. It is based on a RISC principle which focuses on executing simple instruction at a high speed. Unlike complex instruction architecture, ARM reduces instruction complexity so that most operations can be completed in a single clock cycle. This simplicity improves execution speed and reduces power consumption, making ARM processors ideal for portable embedded systems. Key features of ARM processors are 32-bit and 64-bit architecture, load and storage architecture, large register set which is available from R0 to R15 register bank, fixed instruction length, conditional execution and low power consumption. If you see 8086 consists only an R0, R1. If you see microcontroller, it consists only R0, R1, R2, R3. Whereas if you see ARM processor, they consist a large storage register capacity of R0 to R15. So imagine how much the size is increased. So this figure shows how the ARM processor is look like. These are the detailed architecture of ARM processor. As like in 8085 and 8086 and 8051, this ARM also consists of a general purpose register which is starting from R0 to R15, and the ALU arithmetic logic unit is used to perform an arithmetic and logical operation, where the memory is used to keep the storage of current running data, and the various control units which is used in ARM processor are read logic, control logic and write logic. Then there will be some input output ports are available. In order to perform any instruction registers are used, and ARM processor is consists of data bus, system bus and instruction bus. The multiplexer are used to get input of various datas and deliver output only to a particular medium. So these are the components of ARM architecture: address register and address incrementer. It holds the memory address for read-write operation. The incrementer updates the address sequentially. Next, register bank. It contains 31 general purpose 32-bit register additioned with 6 status registers, and it stores operands for ALU, multiplier and barrel shifter. 32 cross 8 multiplier. It performs multiplication of a 32-bit number by an 8-bit number, works closely with the ALU for arithmetic operation. Parallel shifter. It performs fast shift and rotate operation which is performed in logical arithmetic shifts, shift data from the register bank before sending to ALU. Instruction decoder and logic control. It decodes instruction fetched from memory, generates control signals for ALU, registers, multipliers and shifters. instruction pipeline and thumb instruction controller. It supports pipelined execution for efficiency, read instructions and control the flow of ARM thumb instructions. So next important one, ARM instruction pipeline. The ARM processors use pipeline to improve performance. In pipelining, instruction execution is divided into stages such as fetch, decode, execute, memory access and write back. Instead of waiting for one instruction to complete fully, multiple instructions are processed simultaneously in different stages. This increases throughput and improves processor efficiency. The pipeline graph illustrates how instruction flow through these stages. So this figure shows the graph between execution flow and pipeline stages. Next is the power consumption comparison. Compared to ARM and CISC, this ARM is getting a very low of power consumption. One of the biggest advantages of ARM architecture is its low power consumption compared to traditional CISC processors. The graph shows that ARM computers consume significantly less power than CISC-based systems. This lower power usage results in longer battery life, reduced heat generation and better performance per watt. This is the main reason ARM processors are widely used in mobile and battery-operated devices. ARM achieves this efficiency through its simplified instruction set and a reduced transistor count. Lower power consumption also decreases cooling requirements, making ARM suitable for compact devices. Performance per watt. Performance per watt is an important metric in modern processor design. It measures how much processing performance is achieved for each unit of power consumed. ARM architecture provides higher performance efficiency compared to traditional architectures. The graph demonstrates that ARM delivers better computational output while consumes less energy, making it ideal for portable electronics and embedded systems. So this is the comparison between ARM architecture versus the CISC Intel architecture. Instruction set: ARM uses simple and fixed length, whereas CISC uses complex and variable length. ARM uses very low power consumption, whereas CISC uses high power consumption. ARM releases less heat generation, whereas CISC releases more heat generation. The battery life in ARM is longer, the battery life in CISC is shorter, and the chip size ARM is very small and the CISC is larger. Transistor count: ARM uses very few transistors, whereas CISC uses more transistors because of complex instruction sets. Performance per watt: ARM is very high, whereas CISC is moderate. Cost-wise, ARM is cost-effective, whereas CISC requires advanced cooling, so more cost-wise. Cooling requirement: ARM uses very minimal, whereas CISC uses very advanced cooling system. Ideal usage of ARM is mobile and embedded system. Ideal usage of CISC is desktop and high performance PCs. Architecture type: ARM uses CISC architecture, whereas CISC uses CISC architecture. Energy efficiency: ARM is excellent, whereas CISC is moderate. So the applications of ARM processor are: ARM processors are widely used in smartphones, tablets, IoT devices, smart TVs, wearable devices and automobile control systems. Because of their compact design and energy efficiency, they are also used in medical devices and industrial automation systems. Their flexibility and scalability allow them to support both low-end and high-end computing applications. Advantages of ARM processor are: this architecture include low power consumption, high performance per watt, reduced heat generation, compact chip size and cost efficiency. Its simple instruction set and efficient pipelining make it faster and more reliable. These benefits have made ARM the dominant architecture in the mobile computing industry. So these are the references I have included to bring this PPT in an excellent manner. So thank you for watching my video. Next YouTube video I will bring with a new innovation topic. Thank you all.